and that are still going to want to link in. So I would describe Chainbridge's thesis that there are going to be a variety of layer ones, but Cosmos's thesis is correct in that interchain communication is very important. Therefore, we need some way to provide a connector or a larger bridge for all of these other layer ones that aren't going to implement IBC. So given that those things are true, Althea and what we're working on with Peggy fits very neatly into that vision, in that we provide sort of an efficient EVM bridge and efficient EVM code for them to hook onto, and they can spend more time managing their sort of meta bridge vision and dealing with the problems that that brings up, rather than the nuances of how exactly to update validator sets in a reasonable amount of gas.
Okay, so given that we are talking about chains that don't necessarily integrate IBC natively, Chris, how do you imagine IBC becoming the standard for cross-chain interoperability?
I think it's worth disambiguating between two layers of IBC. So there's the IBC core protocol, which is the low-level plumbing Greg was talking about. That handles cross-chain state verification, packet routing, dealing with light clients, dealing with connections, channels, all the topological accounting, etc. That's separate or on a separate layer from the application level protocols of IBC. The application level protocols of IBC are ways of standardizing what the data in packets means. So you can think of them as a kind of cross-chain call data standard, just like ERC20 and ERC721, the non-fungible standard, have specific call data encodings that you can invoke to call certain functions, which are of course not designed for cross-chain interoperability. They're designed for the EVM. But an analogous set of standards can be developed for cross-chain token transfers, non-fungible token transfers, voting, staking, anything you might like. And that set of standards is independent, more or less, of the underlying physical packet highway and security toll booths or whatever. So the core protocol of IBC can, if both chains support it, be used, but if both chains don't support it, instead you can use Chainbridge, or in the case of bridging to Ethereum, you can use Peggy. And in many cases, you'll be able to still speak the same kinds of packet standards. Now, this is really nice because it means that applications can abstract away safely from the plumbing of the protocol. They can just worry about when they're getting packets, how do they process those packets? Maybe even the bridge can change over time. Maybe initially it's Chainbridge, then chain support IBC, or maybe which bridge is used depends on the value of the packet being sent. That all can be automated at a kind of infrastructure layer that decentralized application developers and users don't need to concern themselves with in most cases.
Mm-hmm. Is it fair to say that, it's not necessarily one or the other that's going to dominate, but rather as long as, one or a couple of them are launched, then the function of cross-chain interoperability could be had?
Yes and no. Again, I would distinguish levels here. I mean, I think there are several kinds of benevolent monopolies we should strive to achieve in standardization. If you want a good example of a benevolent monopoly, the TCP/IP standard is a benevolent monopoly. It is very helpful for everyone to be able to use the same standard. It means when you buy two routers, one at a store in Shenzhen and one at a store in Brooklyn, they work together. That's amazing. We should try to get the same thing for applications running on blockchains, assuming that the standard is reasonably well designed. It doesn't do anyone any good to have competing standards which don't do anything fundamentally different, but just wire encode the packets differently or something. So there we should strive for a single thing. What it's called is less important than that we agree on a reasonable standard. Mm-hmm. At the infrastructure layer or the packet highway layer, what technology gets used is going to just depend on the specifics. So for chains with Tendermint, which support IBC, with Fast Finality, which support IBC, and have efficient light clients. The IBC core protocol is probably a pretty good solution for chains which don't, or which want to make use of the sort of additional computation that you can offload to something like Chainbridge. Then Chainbridge is a good solution for chains which have very, very specific engineering requirements to bridge to, like Ethereum. Then the fantastic low-level engineering work done by Althea on Peggy is a good solution. It really depends on the specifics. And all of those can, I think, coexist quite happily.
Right. So let's start going into the specifics, right? It's yeah, one of the key things that we gotta disambiguate is the security assumptions underlying each protocol. So yeah, let's just dive into that. Let's just start with Chainbridge.
Basically, as I was saying before, we have a relayer set that needs to, or a validator set, I think we call them relayer sets now, that's required to basically perform the on-chain actions. Currently, because we focus a lot on, how to actually build it out, our current setup is a threshold voting scheme. Technically, it's trusted. There's no stake involved right now. That's on its way. We're doing kind of the research for that. And I guess we see it as like there's two kind of security models, right? There's the one of the actual relayers, those that are posting to chain, and then there's also that of like what is happening on chain, right? So from the relayer perspective, right now we're currently at a threshold voting, which is basically, like it's a multi-sig style. If you want to think about it that way, you need X amount of people to vote on it. There's some block timeout, stuff like that, depending on the chain. Now, once some other things, and one of the things that like I was trying to explain earlier is when it comes down to security, we try to push it to the lower level side and try to keep it to the implementation or the given chain, right? So as I was saying before, if it's an IBC compatible chain, we can leverage what IBC security assumptions are, right, for that side. And if that chain, if chain A is IBC compatible, chain B is not IBC compatible, we can create that integration. That's what we're looking into now, to basically say like, hey, can we make this IBC compatible, like this chain, like pretend to be IBC compatible, because the relayers do the necessary work to actually conform to the standard. There's like a handshake process with an IBC, and in order for that to occur, you need to actually like be able to prove certain things. And we can do that. Then perhaps you post that stuff to chain. It comes down to the implementation. For us, we're trying to make it so that it comes down to how it wants to be done per chain. It's more of a per chain security model that way. We're getting on our way to like a more staked setup, so that relayers are staked. It becomes a little bit more decentralized that way. It opens up a lot of attack factors, obviously, and that's why we're being careful about it. And that's why we chose to be a more trusted threshold setup at the beginning. And yeah, that's, again, like trying to be more of a framework for allowing you to perform these actions. So therefore you can kind of choose how you want your security practices to be. Right now with Celo, we're adding threshold voting because they're EVM compatible. That's actually going to end up becoming backwards compatible to all EVM chains that are supported, which is great. Obviously it's going to be certain things are more expensive on certain chains, and that's where trade-offs need to happen. And within Substrate, we plan to add that kind of ability there, so you can do the light header proofs there. There's some work being done by some other parties, and we're just going to, depending on where it's at, we'll happily integrate it. Similarly on Cosmos, if we have to go and implement it, that's where IBC is great for. It's like plug and playable for us, and that's the idea. Without rambling on too much, that's like the general gist of like how we view security, at least. And that's, we'll implement it. The implementations we have are based on examples and use cases that we've got set forward right now. And until we get to a more decentralized setup with the relayer set, everything's kind of up to how the chain implements it.
Right. So how do you become a multi-sig signer, essentially?
Yeah. So right now, as I said, it's like very trusted in the current setup. Down the road, it would be staked. So collateral to basically become one of the relayers on the chain. And we're still a few months away from, fully ironing out the final details for how that's going to happen. but we're looking to get that out sometime sometime in the future, the really near future.
So, well, specifically, how do you become part of the trusted set of multi-sig signers right now?
Oh, okay.
Relay,
right. So yeah, sorry. So right now, as I was saying before, there's a couple optimizations we're making just to make things a little bit more cheaper and efficient across the different kind of setups. And until we do that, which is going to be a kind of like a pre-V2 release, right now everybody's running independent setups that will then converge into like one greater one. So the Centrifuge, who's running our parachain substrate-based side, they're going to be setting up their own independent one, and Celo will set up their own independent one, and Ethereum Classic will have their own independent one as well. And then eventually the idea is once we kind of get everything to be a lot more efficient, we're going to go and combine them. Probably, details uncertain, probably we'll just set up like, one or two parties from each of the one or two signatures from each of the parties will be a relayer at the time and slowly open it up. Uncertain, but I could assume something along those lines.
Gotcha. Security assumptions of Peggy?
So first, I'm going to disambiguate a little bit about the peg zone, the like larger vision of an IBC peg zone, and then I'll talk a little bit about what Althea is doing. So the concept of a peg zone, which you hear thrown around a lot, is essentially a zone. So it's a zone. So it's a Cosmos chain that uses IBC to link many different chains and maybe pegs some other assets. Now with IBC, IBC is meticulously engineered to not have to have fewer problems than you would end up with when bridging to an EVM chain. So for example, you can't just have a peg zone with no native token value holding $10 million in DAI in a contract on Ethereum. That can't work. You need some other security assumptions on top of that, which is why you get into like chain safes, relay staking. You really need to add new security primitives. Now, what Althea is doing is that we definitely recognize that the full vision of a peg zone where you can just spin up a zone and that zone has little to no value and just facilitates bridging is great because it's more security for the user, less trust for the user. That's obviously the ultimate vision of a lot of things in blockchain. But right now we're missing the fundamentals. We're missing a fundamentally efficient bridge to Ethereum. There's nothing that's really production ready yet. That's really something you can go and deploy to Ethereum today and use to bridge to Cosmos today. And we're big believers in the value of having something today, because being in the internet business, a lot of the people we provide internet service to, they're like, oh no, you're going to get service from, you're going to get fiber in 5 years if this project works out. You're going to get, it's always like, eventually it'll work, but somebody has to deliver today. And that's sort of why we sat down and we tried to pare down and ask, what is the absolute minimum peg zone design? What is the minimum trust? What is the minimum set we can make that does this job? And the answer to that is that we designed what I'm calling Althea Peggy right now to only do bidirectional ERC20 transactions and just act like an efficient multi-sig for the validators. So essentially, there are no different security assumptions other than you're trusting the validators with your money. That's it. There's no staking for relayers because the validators themselves are observing Ethereum baked right into the Gaia binary. So you don't have a relayer you have to trust because every validator is a relayer. Every validator can observe Ethereum. You don't have to do anything to support staking because that's already been done in Cosmos. You don't have to do anything else to support all of the staking edge cases and all of that, because once again, that's already done in Cosmos. You just go in and add, one more slashing condition there, one more slashing condition here. And you can provide security guarantees, a very specific type of security that's not necessarily as expansive as the full peg zone vision, but you can provide it quickly and simply and focus on efficiency, like reducing the cost of sending transactions across the bridge. So even though it costs something like 25 cents to send so it costs like 25 cents to send a basic Ethereum transaction right now. And to update the validator set in our PEGI contract, and obviously this is not quite done, but I don't expect it to change significantly, costs about 80 cents. So that's doing full weighted powers voted verification and a storage operation. So we really focused in on saying, well, if we design the security model such that we trust the validators, essentially the same trust you have if you're using the Cosmos Hub now, then can we do this very efficiently? So yes, in short, the trust model of Althea PEGI is it's a validator multisig. It is 100% based on whatever trust you have in the destination Cosmos chain. And it's limited to moving only ERC20s. But in exchange for that, in exchange for those downsides, you get an extreme design simplicity and extreme efficiency. And you have the benefit of we create no new game theory security vulnerabilities. We don't have to game out anything new. We're writing code, and as long as that code runs correctly, it's just purely writing correct, efficient code as if you're writing C or whatever. There's no game theory to work out because that's already done in Cosmos, and we can just lean on it.
Keep it simple, stupid.
Yes, that is 100% our design philosophy for everything is to try and create complex outputs with very simple designs.
Yeah. Similar to the design philosophy of Bitcoin, I would say.
Yeah, except, primitive, so simple designs are only limiting when you let them ossify. Because if we have an efficient weighted powers voting validator code for Solidity, I mean, I'm sure that's going to get grabbed by essentially any project, even if they're not actually using PEGI. They're going to be like, oh yeah, you can do that cheaply. So there's a difference between, and I think Chris has been thinking about this problem a lot. There's a difference between an ossified standard that would be a lot like Bitcoin or Ethereum, which they're ossified because of their success. So that's also excellent. And pure technical innovation. Because in the same way you can say Bitcoin is what allowed all of this blockchain development to happen. So in the sense of good low-level engineering, it was extremely productive in that sense. But it failed to make a flexible standard, and trying to hit that middle ground. And I feel like especially we're all talking about bridging chains. So we're all acutely aware of how technical decisions made for low-level optimizations can accidentally cut off a lot of future expansion. So there's a balance to be had between simplicity and functionality that's really hard to appreciate, because when you look at a design, you don't see everything they didn't do or everything they thought of but realized would break stuff. And people have a natural tendency to be like, oh, that works? Of course it works. Of course things work. Things just work, right? But we all know, anybody who's built anything knows that's not how reality works. So yeah. The best engineering always goes unseen.
Yeah. Chris, do you have anything to add to that in terms of how IBC approaches this?
Yeah, I like Justin's description of PEGI as a concrete, efficient protocol built to solve a simple problem that can be built upon and improved in the future. IBC also aims for a sort of minimalism, but IBC is trying to solve a very complex problem. And the way IBC tries to retain the design flexibility and prevent future ossification is by taking the opposite position on the spectrum from concrete to abstract. So IBC is an abstract protocol. It does not have specific operations, specific signature algorithms, specific concrete costs. Instead, it assumes the existence of some lower level protocols whose implementations remain unspecified. They're simply interfaces, so they have to provide certain features such as light clients and the ability to read and write state, the ability to verify proofs. And then IBC lists out what those specific properties are and describes how to build the cross-chain verification, packet send receive, handshakes to deal with dynamic topology, describes how to build the interoperability layer on top of those primitives. Now, our idea, which has yet to play out, but our hope is that the underlying primitives will continue to improve over time as engineering advances are made in more efficient light clients, as engineering advances are made in different kinds of proofs, as engineering advances are made in, perhaps even as parts of the protocol are simulated, as Greg mentioned, Chainbridge might do. But the agreement on a protocol can remain. And the agreement on a protocol is essential because it allows two sides to speak the same language. So even if, Chainbridge speaks IBC using some internal implementation, and the Cosmos Hub speaks IBC using some other internal implementation, Peggy speaks IBC using a third internal implementation, just as three different routers one can use some, one can be emulated on a CPU, one can use some super fast ASIC, and the other one can be built in Minecraft. But as long as they all speak the internet protocol, they can interoperate, albeit the Minecraft one rather slowly. And that is sort of the IBC's approach to incorporating future advances without ossifying.
I'm just going to call out that we have 15 minutes left before the 1 hour mark. And so if you, the audience, have questions, go ahead and put it in the chat box, and then we'll address it in the last 30 minutes to an hour of this live stream. But for now, let's zoom out away from the abstract and into practical usability. What do you, we've been talking about bridges, but there's something that needs to be explicitly said about why we are building bridges. What immediate use cases do you see emerging out of layer 1 bridging? Why is it needed?
I think I can take that one. So Althea has sort of the most immediate and concrete use case in that we have customers, they need to buy internet. The financial on-ramp goes to Ethereum. Ethereum's not fast enough for for bandwidth micropayments, and it also doesn't provide primitives for state channels. So sorry, by that I mean Ethereum does not provide an opcode that would help you make a state channel at a very low cost, which is the sort of thing that would make a lot of sense, but hasn't really happened yet. So the best alternative is a fast sidechain. And if you're looking for a fast sidechain, Cosmos is one with security assumptions and the sort of sovereignty philosophy that appeals to us, specifically because Althea wants to make a blockchain for telecom. And the reason we need bridges is because we want to interact with chains with maybe different security requirements or different uptime requirements. But we know what we need. We don't necessarily know what everybody else may need, but we know that telecom needs a chain that is up all the time, that works very carefully on what changes at the lower level, that can process a lot of transactions, but has different transaction validation rules. So we may want to have a series of like deterministic liveness rules for transaction validation, such that no address can be starved of abilities to send a transaction, because it's more important to be able to get a transaction in than to have a perfectly fair fee market. And it's things like this that are really why I ascribe to Cosmos's vision of mini sovereign chains, because it's difficult to build a system that works for everyone. And typically the alternative to building a system that works for everyone is building a system that is so easy to use and so capable that everybody builds the system that works for them on top of it, which is also sort of the direction Cosmos is going. But yeah, so we envision that users will deposit funds onto their home Wi-Fi router using any blockchain. I hope to support more than Ethereum someday. These funds are exchanged for a stable coin sent across to the Althea blockchain, where they can then be transferred quickly, effectively, and with very known properties to ensure that infrastructure has to remain up, and the interoperability that blockchain provides in the terms of letting people build internet service in a way that's different than it's built now, in a way that lets people peer closer to the edge, sort of bring the core of the internet out, is Althea's vision there. But in order to do that, we have to be as reliable as the existing core of the internet, and that's not an easy task. There are hundreds of very, very capable engineers with millions of dollars working on that exact problem right now, and they don't have the extra complication of a blockchain. So we need to be very conservative about our design, and we need the sovereignty to make sure that we can do what's necessary to achieve that goal.
Well, what's the problem with the core internet now, such that you feel compelled to bring it to the edges?
Okay, well, I have a quick explanation for that. I'm sitting here in Raleigh right now. I have fiber to the door, so I'm one of the privileged top, I think it's 10%, the number increases a little bit every year, of Americans that have fiber to the home. Actually, it's probably still less, because I only remember the 3% number from like 2008. Of percentage of Americans with fiber to the home. So I have conceivably what should be really great internet. My internet hits the data center, not in North Carolina. It hits the data center almost 300 miles north in Virginia. And the reason for that is because AT&T does not want to peer locally. They don't, so the internet is a cooperative open system in which people can connect to each other and provide internet and help route traffic across multiple organizations. No one company could build the internet, because I could no more lay 1,000 miles of fiber in India or China than someone from there could do so in like America very easily, just because national barriers, security issues. No one person could build the internet, and that's why it's so powerful. But for the last mile, we come in with the inherent assumption that there must be one provider that owns the last mile, and that creates really weird incentives. Because AT&T, my internet provider here, because unfortunately the local Althea network is not quite grown all the way here yet. We're working on it. So they peer out. They want to increase the distance between them and the nearest internet exchange to the core of the internet, because that makes it harder for people to compete with them. Because if the core of the internet is far away and you need to run a longer fiber cable to reach it, then you can't compete. You can't peer locally. And this makes my traffic worse. I have triple the latency to the internet exchange that Althea customers have, because I'm farther from the internet, because I don't peer as often. But the reason that happens is because peering is complicated. It takes, and complicated in a social sense. You have to go to a conference, or call up a major provider, and you have to figure out how to work with them to connect your server to theirs, and you have to agree on terms, and you have to agree on how to pay them, or whether or not you should pay them, or where to put the equipment. And with Althea, we can reduce the entire payment negotiation layer of this to you plug a cable in. It's done, because Althea's pay-per-forward networking scheme allows allows everybody in an arbitrary hop network map to be fairly compensated for the way their traffic traverses. So now, instead of having internet exchanges be few and far in between, because it's difficult to arrange that cooperation can happen in the field. Right now, if ISP A and ISP B are in the same town serving the same customers, they just double their costs because they can't cooperate. There's no way for them to sit down and agree on there is a way for them to sit down and agree on a fair way to exchange data, but it takes months, and there's no standard protocol for it. With Althea, it's plug and play. It brings that open cooperation that makes up the core of the internet, that makes sense when you're a large enough company, and Google just wants everybody on Comcast to be able to access their services. So it's very easy. You're just like, of course, we can just plug into each other and we're done. And there's no need to pay each other because we're both benefiting. Why can't that happen at the edge with micropayments using Althea? And that allows the internet to be better and more available and more open. And I've touched on a few parts of the incredibly complicated question of why so many people's internet is poor. And that is because it is difficult to, and that is because of all these cooperation problems where, if there are two ISPs in a town, both of them lose. That shouldn't be the way things work.
Got it.
So I think that's the short summary, and probably still too long.
Gotcha. Yeah, cool. What do you, Chris or Greg, see coming out of what sorts of use cases do you see coming out of these layer one bridging?
Well, again, I'm going to take the abstract position to Justin's concrete. IBC exists to enable projects like Althea to exist. IBC itself does not have a particular use case. And I think it's not so much that interoperability protocols enable use cases that single blockchains don't enable. It's that they change the economics to render use cases that would previously have never worked workable. So if Althea had to build on Ethereum, all of their operations would be too expensive. And they would not really be able to change any of the code without going through this, very convoluted, unpredictable, not even written down Ethereum governance process. Moreover, they would be competing for transaction space with CryptoKitties. So, when someone launched a new version of CryptoKitties, when someone launched, crypto space monsters, looking at someone's avatar, crypto space invaders, then everyone's internet would go down for 24 hours. That seems pretty bad. Clearly, Althea would benefit from sovereignty, from the ability to control all of the logic on their own chain, from the ability to upgrade it when they wish, from the ability to control the kinds of transaction inclusion rules they have, and protect their little walled garden of internet payment transactions from a big bad CryptoKitty rushes. And IBC exists to enable Althea to go ahead and do that while still talking to other chains, which have assets they need to interoperate with, which might have user accounts, which might have other data that needs to be shuffled around every so often.
Mm-hmm. Yeah, this seems like we're actually bringing Plasma to production without going into any of the data availability problems. But architecturally, it looks a lot like Plasma, in that all of these applications get abstracted into a separate sidechain. Anyway, Greg, how do you view use cases emerging out of this chain bridge and this world of networked and bridged chains? I guess specifically as it pertains to DeFi. Oh, can't hear you.
Sorry. Hey, there we go. I was just thinking, no, this whole time I was like, are we gonna go this whole time without DeFi? But
I know.
it made it.
It's the obvious thing.
Yeah, it always is. I mean, Justin kind of tiptoed around it for like a good 10 minutes there. He was, he was talking about tokens and all sorts of stuff, but didn't quite say it. Yeah, no, I mean, like a happy medium between kind of what Justin and Chris said. I think they both kind of really nailed it on the point. Just briefly, like one of our big use cases is Centrifuge, who's doing it specifically for DeFi. They're taking all, like documents and NFTs across from Substrate over to Ethereum because for their specific use case. We also have Aragon Chain, who's building on top of Ethermint within Cosmos, right? And like their main use case is very similar to Alethea's, which they're trying to take control of their chain, take control of it, still have a lot of their main state and a lot of their main DAOs like happening and occurring on Ethereum, kind of like some finalization stuff there. But at the end of the day, they want cheaper transactions. They want to do a lot more experimental things and things like that. And that's why it makes sense for them to be able to. And in their use case, similar, they're going back and forth quite a bit, right? They have DAOs. The idea is like DAOs communicating with DAOs across different chains, DAOs executing calls across chains, which is where things get really cool and things get really fun ultimately. So that's what we see a lot of. And I mean, lately in the last, 2 months, I guess, we've seen a lot happen in DeFi, especially when it comes to bridging. I mean, we're at like, I don't know how many like actual units of Bitcoin. We actually like how many Satoshis are on Ethereum right now, because it's always in USD value and it's like super inflated. But I think we're at like 10 million plus, or maybe even more than that, of like Bitcoin that's already like made it over. We in the past, and that's being traded now, and it's collateralized, I think, even against like MakerDAO now, or against DAI. It's pretty incredible to like see it, and like that's becoming, obviously, because DeFi is such a big use case nowadays. It's kind of taken over a lot of the transaction space, especially on Ethereum. We're seeing that, you know, synthetic versions of native tokens from of the native like fuel asset on most chains are like starting to become synthetics on Ethereum, so that you can go and wrap them into futures, you know, and do all sorts of stuff on it. And that's definitely a big use case. That's what a lot of people and a lot of you know, organizations that we're working with, like it does focus and center around that stuff, around DeFi and how they can, you know, bring DAI to their ecosystem. Be simply because it just makes more sense to lock it up, transfer it over, and use that as their stable coin versus trying to actually create the whole ecosystem around it, a new ecosystem around in their current setup. I think that's where a big use case is going to be, and like kind of like how Justin and Chris both said it. You know, like Ethereum is congested to some degree, obviously, and you know it's becoming the DeFi hub. Also, you know, like everything's really happening there. And it's a matter of like, how can you kind of like leverage this across different chains? And we definitely see we're taking a little push there, definitely on the chain bridge front. We've got some ideas on how we can actually help streamline that. Similarly to how Aragon's able to make cross-chain calls, you know, we're looking at the similar stuff. And I think that's where we'll see a lot of use case right out of the get-go. And it's exciting. Oh, my headphones just died. So yeah, I guess like aside from like you know what Justin talked about, needing to be able to do things cheaply, and Chris like being congested, like those are like DeFi is like obviously the big next use case, and we're already seeing a lot of it, right? That's pretty awesome. Yeah, I think that's everything.
Something that's unprecedented in the DeFi space, right? Something that they have not had to contend with so far is the is staking. So has anybody here thought deeper about the implication? What would happen with the incentives of staking in the presence of DeFi?
Yes, it keeps me awake at night. I think it is terrifying.
Yeah.
If there is one serious threat to proof of stake working in practice, it is DeFi.
Right.
I have seen nothing else comparable. I mean, now the one point, you know, one reason for optimism is that unlike the traditional financial services sector, all of what is done on blockchains is necessarily transparent. So it can be analyzed. You can see if there is in fact collateral backing your transactions. You can check what is the net economic impact of this transaction, and is it safe? Now that analysis is complex, but in principle it can be done. Nonetheless, I think it will be necessary for proof of stake systems to interoperate carefully with DeFi. And this is one reason why sovereign security is so important, because it makes interoperation opt-in. So if you want to, you know, limit transfers of your staking token, or there's some things you can't guard against, like if someone can verify the state of your chain, they can always create options or futures. But sovereignty, I think, will be an important component in, you know, picking and choosing among the kinds of decentralized finance you want to interoperate with, and choosing carefully so that they don't put your proof of stake security model at risk.
Yeah. Concretely, how do we do that, right? If we say, you know, there's almost 4 times more value locked up in DeFi on Ethereum than there is like total staked in Cosmos. You know, how do you build dams around that? How do you, you know, simultaneously unlock all of the value in DeFi while giving Ethereum additional throughput, while not breaking Cosmos?
Right. Well, there are 2 dimensions of risk or consideration, and they are distinct. The first dimension is simply complex layered derivatives changing the security model so much that no one understands it anymore. This is, you know, pretty much analogous to what happened in, say, at least at a very high level, the 2008 financial crisis, when there were mortgage-backed securities so far abstracted away from the underlying assets that were collateralizing them that no one understood what was going on, you know, including plenty of PhD economists. Now, some of this is easier because things are transparent, like I mentioned, but chains still need to be pretty careful to, derivatives sent around to all these places don't, don't end up being collateralized with nothing at all. Now, that's only dangerous if you allow things to collateralize your proof of stake that aren't actually secure. So that one's pretty easy to prevent. You just only allow a specific asset. But the second dimension of potential risk is in all this cross-chain verification being used to create contracts which change the incentive structure. So there's nothing that prevents you from betting that some chain is going to fork. And you could, in fact, pay validators for forking the chain. And you could pay them in a trustless way if you have cross-chain communication. So you could create, using all these fantastic bridge technologies that we're building, you could create a contract on some chain that only pays out to the validator set of another chain when the other validator set of the other chain equivocates or violates the rules of the protocol. So that, is another thing you have to be potentially concerned about. And you need to reason carefully about what collateral is backing your proof of stake. What will the costs to validators be if they break the protocol? Are you making sure that you're not securing more value than those costs actually are? Are there any ways individual validators could get paid to defect, which would be problematic? A lot of careful reasoning needs to be done there.
So we've got chains attacking other chains.
Right. I mean, the sort of meta level, I'll say one more thing and then I'll stop talking, but the meta level tactic we can take here is to ensure that our interoperability systems build, in the metaphor of highways, they build ID gates is not the right. They build gates between the different blockchains, and the gates track how much value went in or out in order to add a kind of fault isolation. And IBC aims to enable this, although of course it's up to the application level protocols to measure the actual value flow and gate things appropriately. But if we have a world of thousands, tens of thousands, hundreds of thousands of blockchains, we need to assume that some of them are going to fail in Byzantine fashion one way or the other. And we need to ensure that users can pick their security models in a way which isolates them from failures of other chains which they do not elect to be exposed to.
Yeah, so you mentioned a little bit about what would be collateralized. There's a lot of discussion in the ecosystem right now about what should be collateralized and what users want to collateralized and who earns the interest, so to speak. Have you guys thought more about that? Because, there's discussions about, using atoms as collateral, but there's also people who prefer not to use it as collateral and would rather have some staking derivative be the one that is collateralized. And then there's also questions of, who the borrower or the lender should be the one earning the interest for doing so. Have you guys thought deeper about that? Maybe not. I mean, it's something that I know, like Tarun Chitra, the people, Chorus One, the people talking about staking derivatives have been thinking about, and it is largely left unanswered, right?
Yes, but who should make the money is a financial question, not a technical question. So perhaps this group is slightly less interested.
Right. Yeah, I'm asking the wrong group of people. Right.
I have an economics degree, but I don't know how much I use that.
Yeah, same here. or rather, yeah, I only know the economic side of things. Yeah. Okay, so with that, let's segue into the Q&A portion and free-form discussion of this meetup. So, Kelsey, are you able to unmute the guests? Or Adriana?
Yes, I can.
Thank you. Yeah, we'll address the first question that's Juan asked if blockchain standards are a lot more like hardware standards, period. Going USB 2 to USB-C requires new equipment. Sorry, that wasn't a question. That was a statement, I guess. Do people in the audience have questions? You could either raise your hand or insert it in the chat box or speak directly if you're able to unmute yourself or be unmuted.
Yes, everyone should be able to unmute themselves.
Okay, great. Does anyone have questions?
So, Chris, while we're just while we're waiting, anyone feel free to interrupt me because this is just a thought I had. What happens if you do ZK snarks enabled DeFi and you can no longer verify where the money even is?
I've not thought about ZK snarks enabled DeFi. DeFi is as a vague reference, but I've thought about ZK snark enabled interchain token transfers. And I think what the part which immediately becomes very hard is that you have two countervailing concerns. You want to, maybe this is not your question, but it's interesting, so I'm going to say it anyways.
No, this whole topic's interesting.
If you have a shielded set that you want to shard across chains, you want to maximize the size of the shielded set because it provides more anonymity, but you want to preserve as best as possible the fault isolation you get between chains. And this is difficult because in the usual IBC token transfer model, you get false isolation by measuring the number of tokens which were transferred and by preventing more than the number of which were transferred in to be transferred out again. So if all the token amounts are shielded, suddenly that doesn't work. Now, there may be ways in which you can build, I was going to try to put this in the analogy, but I couldn't quite manage it. So you could build temporary secondary circuits where you provide some additional information in the proof and have to keep your token when you transfer tokens cross chain. This changes the security model a little bit, but you can instead put the tokens in a purgatory. And while they're in that purgatory, the amount is still shielded, but if misbehavior is discovered, say within 3 days, then it can be reported to the chain and the purgatory tokens don't affect the supply. So you can still have certain kinds of fault isolation, but you have to design it much more creatively if you want to shield all the amounts sender and recipient. Now, as for ZK snark,
I think we've got a question. We should probably answer it before we go too deep into this, but I'd love to have a conversation. In fact, we should probably just have a call on this subject in general, just like all get a beer and just have ZK snarks conspiracy theory making for an hour.
Okay, Jake asks, how long before we can use these approaches in production?
I mean, from our perspective, or from our side, like on the Chambridge side, we just completed our audit of our base V1, and I think we're making a few upgrades to it, but outside of that, you could use it today. You can bridge between EVM and substrate based chains, and you could get into the Cosmos world quickly that way if you were to spin up an Ethermint chain. But yeah. Awkward.
Well, I can quickly answer on behalf of IBC. Hopefully everyone gets unmuted, but IBC 1.0 will be launched later this summer. You could use it in production now. It does work. That would be at your own risk, but it's all open source, so you're welcome to. Even after it's launched, it will be at your own risk, to clarify.
How did the Game of Zones end up going for you guys with the IBC?
It went pretty well. Certainly we found a few bugs, but by the end of it, I think there were over 100 chains sending tokens around to each other, including lots of multi-op transfers, fancy stuff, people playing around with clients.
feel like Justin wants to say something along the lines of "it works." No, close. Let's play sign language or charades. Let's do charades. I think I know who's. Oh, I think Adriana can unmute everybody. I think I was muted.
I am.
Yeah, there we go. I was stuck muted. Something weird happened where I muted myself, and then it made it so only the host could unmute me, and it was, anyways, some probably little logic tree in Zoom's code base that nobody pays attention to. But anyways, so for Peggy, we are hoping to have something production ready by the end of now. I should clarify this. Production ready means that you can run it, and there's no obvious reason why it will explode and need all of your tokens. Obviously, you run almost anything in the blockchain world at your own risk. So, but so I'm hoping to have Peggy ready to be deployed in a production, but probably you wouldn't want to put $10 million in it by the end of the year. And then we're hoping to have more of a audit situation done and that sort, and have something really solid a little bit into next year. So yeah, obviously we with the Althea zone have a sort of immediate use case, and fortunately it's not an ICO, so that means it's not going to be holding all of the money right away. So that makes it somewhat easier to do sort of a soft launch and have a smaller amount of money in it for a while we sort of play around with it, but it still be in a production context.
Yeah, I do have some questions left over that we didn't answer during the interview, and so if we could continue going down that path while you know, the guests have questions later on. So yeah, one of the outstanding questions was like, how does each address forks, right? If a main chain forks, right, Ethereum, for example, let's say Ethereum forks after I don't know, it forks 6 blocks out. How does each of the protocols contend with these forks?
So for Peggy, at least, we are currently working on probably a 50 block delay before we do anything. So 6 blocks isn't going to do anything for exactly this reason. But assuming Ethereum had a more permanent fork, or assuming that we wanted to operate much faster, you know, much closer to the head of the chain, what would happen is that the same validator set would then just control the contractor, or the bridge holding all the funds. Think of it as a giant multi-sig weighted powers wallet, weighted powers multi-sig voting wallet, to use a mouthful of a term for it. They would just control that on 2 chains, and it would mostly be a matter of that's mostly a matter of what does the Cosmos chain want to do with that money. For example, let's say the Ethereum and Ethereum Classic fork were to happen while Peggy was deployed and running. To support that sort of thing, we would probably want to add governance vote support, where you could have a governance vote and be like, this is the one chain we're going to continue updating, and maybe we just want to move everything in the other chain, sell it off, or maybe we want to keep it, maybe we want to do both. You would definitely need some sort of governance action there, because that's inherently that's not an inherently technical decision. The other thing you might want to do is add support to so if there was a fork like that, both chains could still be updated with the same validator set updates. So it would sort of be a neutral situation, as long as at least one validator was looking at the other chain and ferrying validator set updates over, then everything would remain neutral until such a time as some sort of governance resolution passed for different behavior.
Okay, we have some questions from the YouTube live stream.
Niraj asks, is Peggy going to be about moving ERC20 in a general purpose way, both ways between Ethereum chains and Cosmos? What about Ethereum? Also, Peggy, sorry, this is a long question. Also, is Peggy going to be just a project others deploy on their own infrastructure, or is it going to be an actual chain that is deployed for others to use to bring tokens to and from Cosmos?
Okay, yeah. So 2 questions there. First of all, for now, Althea's reduced scope, simplified Peggy includes bidirectional ERC20 support, which means you can send ERC20 to Cosmos and you can bring it back from Cosmos to Ethereum. And that doesn't include, for example, bringing an asset from Cosmos and representing it as an ERC20 on Ethereum and like minting tokens when it comes across the bridge. That's not in scope yet, but that is something we would like. Because, you know, despite Chris's warnings, the temptation of having Atom on Uniswap is just too much. Then for the second question, Peggy will be an application that anybody can run on their own Cosmos chain. And the larger vision of a Peg zone, after which Peggy is named, does include what you described, where there is one chain to do all the bridging for everyone. But the security assumptions you need for that are more complicated than what we wanted to implement. So by sticking to Peggy as an application the validators run that assumes the validator's trust profile, you can dramatically simplify the implementation, and that's why we are doing it this way. I notice questions from, okay, that's Niraj's question. Is there, oh, the third question is also from Niraj. Thank you, whoever pasted this in, thank you, Django, for pasting this into the chat. Relayers would just randomly not work. Is that resolved? So for the third question, it's a question about, for the stream. My apologies.
Questions. Yeah. I had noticed that Peggy had unpredictable issues where the database was in use and therefore relayers would randomly just not work. Is that resolved?
Yeah. So for our implementation of Peggy, so Althea is going to be simplifying the relayer, streamlining it, and integrating it into and integrating it directly into the Gaia binary, such that all validators are also relayers. And we are hoping that we can dramatically increase the reliability and make it a lot less trouble for the validators by having it just be like, oh, I'm running a validator and now it won't start. It's like, give me an Ethereum node address or I won't start. So the validators shouldn't even have to really worry about that. So yeah, we have not yet begun work on our relayer improvements. So that's a little bit pie in the sky right now, but I think we can get there and we'll be there in the next month or two. So yeah, I hope that answers your questions.
Cool. No more questions from the audience so far. So going back to the question of how does your protocol contend with a fork? Let's talk about how ChainBridge does it.
Yeah, for sure. So I guess like, especially within context of networking, and I guess people within the Ethereum ecosystem might conceptualize this a little bit better, is like, I guess there's like 2 types of forks we can see, right? We can see that like, you know, there's like an actual somebody trying to like maliciously take, and then there's just like simply networking. There's a lag or latency. You didn't pick up everything, and you know, the node you're tracking and following branches off, and now we have like an orphan block. In both cases, like similar to Peggy, we're simply implementing right now a block delay. It's simple, it works, it gets the job done, you know. There's nothing really fancy. Something that we've kind of like chatted briefly about internally is kind of this idea that, you know, as long as you have diversity of the nodes you're connecting to and between the relayer sets, and ultimately, you know, there is this delay, technically you're always looking at the right thing, right? Until you kind of like reset and go back. And assuming you have a threshold voting system like we do, it'd be pretty hard to you know, unless every single node got knocked off and or every single relayer was like focusing on a node that actually forked, which is highly unlikely as long as you're diversifying the set, you know, you should always, again, as long as your threshold is fine, as long as you always have a adequate number of people, like maybe 1 or 2 of your 10, 7, however many relayers you have would be knocked off onto a different fork. That would be like realistically what happens. So at least we have like still a majority of them on the correct one. Kind of comes down to like, you know, that idea of like geo redundancy for servers and whatnot. It's like the same idea, as long as you have redundancy over the different nodes you're connecting to, so they're not all like Infura based nodes. Maybe you're running a few yourself, you connected to whatever other block node providers. That helps. Like you can only do so much at a code level. That's why we implement like a block delay, right? And then at that point, it's about educating your relayers, educating everyone. Similar how you educate stakers, right? In the Cosmos world, on how to like stake their atoms in an efficient way, so that like, you know, they're protecting themselves in the network.
Mm-hmm. So if you're implementing epochs for block delays in order to finalize, does that mean your block finalization is a lot longer than 7 seconds? It's just until each main chain finalizes to a given block height?
Yeah, pretty much. I don't have the number off the top of my head of what that looks like. I don't think it's as high as 50, as Justin said, but like ultimately it's arbitrary, and depends on the implementation and like the chain you're looking at too, right? Because for a chain that actually has finality, if that finality is instantaneous, if it's 6 minutes, like an ETH2 or whatever, like it really depends on like also how much you're willing to risk. Something we've toyed with is the idea of could we implement a system where, you know, the user chooses the risk profile, right? Like because, you know, our idea is all about like making it as modular for you as could, like the user itself say like, hey, my risk profile is like, I want it instant, 1-2 blocks, really don't care. Then you could potentially make the transfer in 1 or 2 blocks. Yeah.
And that's what Casper, the friendly finality gadget, wants to do, right? It's like Vlad's design of Casper.
Yeah, CBC. Can't say I follow it too closely. It's quite loose-ended still, I think. Yeah, but
yeah.
Same.
From what I remember, that's like he wanted the users themselves to parameterize their risk profile.
Yes.
Rather than do some top-down thing.
Yeah, it adds a lot of complexity. You know, simplicity is just the block delay, like Justin says. So.
Yeah. So is this so variable epochs per chain is going to be implemented on ChainBridge because you're doing it for various different chains, right? So like if you're doing it for the Polkadot chain, that would be different from ETC, for example, or Celo.
Yep. Yeah, exactly. You know, like an EVM based chain that doesn't actually have finality, like doesn't have like, you know, the hard probabilistic finality and whatnot. And it's more open-ended, you know, the safe bet is to apply like something like a 50 block delay, right? Like Justin said, you get into a world of like Cosmos and Polkadot, it could be totally different. Depends on how it's implemented. It depends on how the chain works and how the consensus works and so on and so forth.
Like who implements this? Right? Is it chain safe if you're
right? So yeah, this is again. So as I said like earlier, right now we have independent parties running them independently, simply because one, we're testing out like the initial phase before we roll out to a larger one. Right now they're playing with their own ideas. In theory, right? This is where it gets kind of complex and kind of, you know, you could have a relayer that looks at multiple contracts on the same chain. So there could be multiple different bridge and bridged like contracts, for instance, in an EVM context. You could, in theory, point to multiple. And in doing so, one relayer could be responsible for 3 separate bridge contracts against one chain. There's a way to identify which one it goes to, where, like how one moves and one moves across. That gets really complex. We are looking at trying to avoid that, but ultimately that is possible.
And why would you want more than one bridge contract?
Again, like these are ideas that have been tossed around, and it's like a risk profile thing. Again, it comes down to like how modular do we want to actually design this. Right now, we don't have any. We don't set them up like this. You know, relayers don't set up against multiple, but theoretically, it's possible.
Gotcha. Right. Chris, on the IBC end, how does IBC contend with forks on the chains that are integrating IBC natively?
Like Peggy and Chainbridge, IBC assumes that forks don't happen because if you try to deal with forks and cross-chain rollbacks, things quickly become exponentially complicated. So I don't have too much to add there. Of course, IBC deals with a lot of consensus algorithms which have finality, in which case forks are expected to be less of a problem. But in the case of Nakamoto consensus, you can also choose to apply a end confirmation threshold to get a finality gadget. The only additional part I would note as an addendum to Greg's point that different transactions often have different values and require different levels of assurance about finality is that I think this is actually an area where a little judicious sprinkle of DeFi can come in handy. In particular, if you have different tokens represent the different finality levels on a peg, so you have like 5 confirmation ETH, 10 confirmation ETH, 50 confirmation ETH, then you can float them against each other in a market. And some users can basically pay a slight premium for a faster transfer and have someone else take on the fork risk. So that actually can potentially, I think, be quite useful.
Gotcha. So somebody on YouTube asked, and this is Niraj again, he goes back to Peggy. He says, so Peggy will be a module I can drop into my existing chain, much like staking, governance, and the other modules?
Yes, it's just going to be a module that you drop in and that you run. It'll be somewhat inconvenient for validators because they will have to find an Ethereum full node that they trust. Because with Althea's Peggy design, we are making it mandatory for validators to observe the Ethereum chain themselves. And that will be a slight inconvenience to the validators in exchange for you guaranteed have as many relayers as you have validators, which is a great boon to a lot of security assumptions. And there was one other thing. Oh yes, our Peggy design as it stands is designed to use batched transactions. So by batching as many possible transactions together, as possible together, you can amortize the cost of moving across chain, because we want to try and get the cost of sending a transfer across the bridge down to essentially the cost of an ERC20 transfer in terms of gas, and that's pretty achievable. So there is an advantage to, for example, having perhaps the Cosmos hub running Peggy and using IBC to get the bridged token over to your blockchain, because IBC is just frankly a faster and more flexible protocol because it doesn't have to deal with the constraints of Ethereum.
Cool. I have one more question, and then if there's no more questions from the audience, then we'll go ahead and conclude after that, shall we? All right, let's do this. What is a conceivable user story for using all of these different bridges in the future once they're all productionized? Has anyone flowed through that?
Well,
sure.
Go ahead.
Oh,
Chris.
go ahead. No.
No. My I've already explained the Althea user story like 3 times now. So.
All right. Well, I was going to incorporate the Althea user story. So the mildly crazy user story I have in mind is that we implement the Circles model of self-sovereign universal basic income, where everyone issues their own personal token, and at some self-defined rate, and people can choose to accept that token or basically extend sort of trust-based credit in exchanging their own tokens. Then we can, when I want to pay for internet using Althea, I need to find a path of people who will extend these trust lines for tokens to get from me to the guy with the router next door who I'm paying per packet for my Althea internet. And that will go over several chains. It might touch Ethereum, it might touch a chain through ChainBridge, and it might utilize IBC.
Okay, one question from the audience. It's from Niraj again. He asks, so the Ethereum link is technically the centralized weakness in that if every validator pointed at the same oligopoly of Ethereum nodes, it is not quite decentralized?
Yes, this is why Infura is not great, and I may actually write something in the full node that if you try and provide it in Infura link, it just crashes and asks, and I don't know, sends you to some really like pedantic documentation of like, why are you doing this? But yeah, this is a known security problem, and that is perhaps why a lot of people may want to. And that is perhaps why many chains may wish to use IBC to get their hands on Ethereum bridged assets rather than decide to run Peggy as a module, because it comes with certain obligations which are inconvenient for the validators, because there's very few things in life more inconvenient than trying to run an Ethereum full node.
Amen. Okay, so any more questions from the audience before we close?
Going once, going twice.
Sold. The auction is closed. Okay, thank you everybody for coming to Cosmos Unchained, the very third episode. We're doing these on a fortnightly basis all the way up until October, so be sure to join. They're usually start in the early weeks of a month and the late weeks of a month, so the beginning and the end of the month, twice a month, so be sure to check in. The next one we have is going to be with Lightning, Roast Beef, and Matt Longo from TBTC. We're going to talk about Bitcoin interoperability because that's a reasonable follow-up from Ethereum interoperability. So be sure to join us on that one. That one is going to be sometime in late July. So just check in. We're going to be communicating that across all of our channels. Be here or be square. Thank you for coming. Bye, everyone.
Thanks, ciao.
Thank you.
Thank you. Bye.